Good morning, class. Today, we are going to talk about something called scientific notation. Now, I don't want you to get scared because you guys worked with exponents before, and this has something to do with exponents. I'm gonna do the explanation. Well, a scientific notation, first, who is familiar with a scientific notation? Who knows what that is? Or at least heard that? Nobody? Amanda?
I heard of it.
What do you know about scientific notation?
I just heard of it.
Or you just heard the expression scientific notation? All right. Now I'm going to explain that. Scientific notation is a way that mathematicians and scientists use to express numbers that are really big in a shorter manner, or likewise numbers that are really small, shorter. For example, when we talk about the human biology, we talk about the human cells. We have many cells inside our bodies. So many. I'm gonna show you how many we got. We got approximately 35 trillion cells in the body. Okay, I'm missing zeros. Right? 35 trillions. We got the 3 commas there. All right? Now, sometimes the number could be even bigger than that number. And now we want to express this number in another way, in a different way that doesn't occupy so much space, because then we're going to be dealing with other numbers. And the way we do that is through scientific notations. Now, how do we do this? We do this by using the power of tens. If you remember, who can remember this? Talking, refreshing on the power of 10. Who remember what this is? This expression. This right here is an exponent, and this is the number. Who can remember that? Anybody? When we have this expressed, this is simply when we got an exponent, the small number there is that you are multiplying 10 by 10, and that's 100. Okay, that's an exponent. All right. Now, with that in mind, we're using that. With that in mind. Now, we also know that the decimal point is right here. This is a positive number. All right? And we are going to use the power of 10 to put this number smaller. And the way that we're going to do it is that we're going to move the decimal point so that the decimal point is right here. So the decimal point got a 1 single digit in front of the decimal point, and then everything else behind the decimal point, or until it gets to 0. All right? So now we know that the decimal point is right here, and now the goal is to move the decimal point to here. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now we got the decimal point right here. and we move it 10 times. Using the power of 10, which I explained before, it will be expressed this way. 3.5 times 10 to the 10th power. The reason we're doing this is because when you are moving the decimal point to the left, the number is decreasing 10 times. Every time you move the point to the left side, the number keeps on decreasing 10 times smaller. And in order to compensate that, we are multiplying by 10. Right? We move it once, we multiply by 10, we move it twice by 10, by 10, by 10, by 10, by 10, and so. But the problem is that at the end of the day, we don't want to have this much numbers on the right. So that's why we use exponents. All right? That's why we got this number right here, to express that in short. So, practically, what we're doing is we're using the power of 10, we're moving and at the decimal point to the left in order to get this answer. And this is the same thing. How many times we move the point? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We move it there, so we got one number in front of the decimal point and the other one. And why don't we put the zeros here? Because the zeros are going to be expressed right here. So if we were to have a number here, another number here, and a zero there, then we will express the other number there and add the exponent there. So, but because we got the zero here, that's where we stop the decimal points to the right to the right of the decimal point. Now, do you have any question, alguna pregunta acerca de cómo vamos a hacer esto? Elian, no tiene ninguna pregunta. ¿Está claro todo? Everything is clear? So, when I give you some practice exercise and you approach a number like this, let's make it smaller. What are you gonna do? I'm checking for understanding. What are you gonna do when you approach this number? Where is the decimal? Let's start by this. Where is the decimal point on this number? Right at the end. And we're gonna express it on scientific notation. What do we do here? Oh, come on, don't be shy. We gotta move it, the decimal point to where? To the left. How many times? Count with me. How many times?
1, 2, 3, 4.
Oh, sorry.
4, 5.
4.
4, 5, 6.
6. So, and the way we're gonna express this is we're gonna put 3.55. The reason, and this is a little different than this one because there's something I'm gonna explain you because they're gonna show you some numbers like this. I put 5 because this is not a 0. So I gotta put times, tens, and how many decimal points? 1, 2, 3, 4, 5, 6. 6. Now, if you were to take your calculator and if you and I'm gonna show you, I'm gonna prove that this number is this number and that this number is this number. Okay, I'm gonna take the calculator. Let's just work with this number. Right here, this means 10 to the 6th power. So it's 10 times 10 times 10 times 10 times 10 times 10 times 10. So let's do that. 10 times 10 times 10 times 10 times 10 is equal to that times 3.55. Okay, yeah, I'm missing a 10. So 10 times 10 times 10, that's 3 times 10, 4 times 10, 5 times 10, that's 6 times. All right, that looks all right. And you multiply that times 3.55 and you get that number. Isn't that the same number? Right? See? All right. Likewise, we use scientific notation to express really small numbers. Really small numbers. Take the cell, the diameter of the cell is in meters. Is this small if we're expressing it on meters? So it's less. We won't see the cell with our naked eye. We see the cell on the microscope, which is the reason it's this small. It's way less than 1. If you take in account how many zeros we got after to the right of the decimal point. Likewise, we can express this really small number in scientific notation. Anybody want to take a guess how we're going to express this number on a scientific notation? Huh? All right. We're going to express it the same way. We're going to go through the same process. But instead of going, since we're expressing this number, it's a small number that is to the right of the decimal point, we're going to do the counting and we're going to move the decimal point to the right instead of the left. Because remember, the point is that we're going to have, the point of this is that we're going to have the decimal point after the number, this number. So let's count with me. Let's do this. 1,
2, 3, 4, 5, 6, 7.
All right, good. So, how many times did we move the decimal point to the right? You just counted it.
5.
No, how many times? We counted it.
7.
7 times. Do we write the 7 like that?
Yeah.
Well, it's missing something. We move the decimal point to the right. So that means that this exponent right here will be a negative exponent. Because we move it to the right side. So 7 times, but you're moving it to the right, is the same thing as dividing by 10. In the other exercise that we did, that we saw that big number, it was the same thing as multiplying by 10. But now we are doing the same thing but using division. And every time you move the 0 to the right, you're dividing by 10. And in order to express that, without a mess to the left of the paper. We just use exponents. That's it. That's it. Any questions? All right. If you were to have any questions, you can always refer to on my YouTube channel to the video that I got on exponents and all and review the exponents, and then go and see the video on scientific notation. I got the video both on English and Spanish. Maybe your parents can help you with that. You know, you can watch the video together, or maybe you guys can get together and watch the video, just in case you forget something, because the video, at least when you're at home, you can go back and see it again many times until you get the concept. All right. And now we're gonna have homework. With the homework that we're gonna have is gonna be page 42, and it's gonna be exercise 1 through 21, not including exercise 17. So everything is 17. Okay. All right. Thank you.